Okay, this is June 5th, 2012. It's 4:29 p.m. and the transit of Venus is this afternoon here from St. Louis, Missouri. I'm in my backyard, and the sun is high up in the sky here in the west, high enough up for us to be able to get a look at it. I'm going to set the telescope probably about here. I can watch the sun set, maximum angle, and I'm going to set the camera up so you can see, and I'm going to use the camera for the timings for first and second contact. Third and fourth contacts are not visible from St. Louis. In fact, the sun will set from here about 8:15. But you can see in our yard here, I'll show you. You've got the sun up in this part of the sky, and you've got some trees and the fence here, which means we can watch the sunset until about 7 or 7:15 before it disappears behind the fence and bushes. So that means the transit will be in process during the sun will set with the transit in process. So I'm going to get started setting up, and I'll be back.
Here's your water.
Yeah, I really don't need to emphasize that you should never point a telescope at the sun without a proper solar filter. So I'm going to set it up pointed away from the sun, and then I'll attach my solar filter. Rear cell cap, and I put the visual back on. I'm going to leave the finder off because it's dangerous with the sun up. You don't need the finder. For this observation, I'm going to use my Teleview star diagonal. Obviously, I don't need this kind of perfect optics for something as bright as the sun, but what the heck? I have it, so I might as well use it. Notice again, I've got the scope pointed away from the sun as we set it up. And I'm not attaching the finder. Just one less telescope to accidentally look at the sun through. So I'm going to attach the hand controller so that we can keep, obviously I can find the sun, it's pretty bright, but the computer will keep the sun and Venus in view for prolonged periods. Battery power cord. Battery power cord. Once we get everything connected and I get my solar filter attached, we're going to make sure that we get the sun in view and that we can track it well before the transit starts. 12-volt battery. Okay, hi, this is Bill Breeden again, and we're observing the transit of Venus this afternoon. It is 4:41 p.m. Tuesday, June 5th, 2012. And do not attempt to look at the sun with any optics, any kind of magnification without a proper solar filter. So I'm going to show you now. I've got the telescope set up and pointed away from the sun before we put the solar filter on. I'm going to make sure that there's not even a chance of accidentally looking at the sun through the telescope. This is a proper solar filter. It's 1,000 oaks. It's a glass solar filter. This is for an 8-inch telescope. It can be used on a Newtonian, Dobsonian, Newtonian, a Schmidt-Cassegrain. I don't think there are many 8-inch refractors, so it's probably not for a refractor. This is a glass solar filter. We're going to attach, I'm going to show you how this attaches to the telescope. Again, do not look at the sun through any type of magnifying instrument without the use of an astronomy approved solar filter. This is a full aperture filter. Don't settle for anything less. If you have a solar filter that just covers the eyepiece, run. That is not safe. Your solar filter should cover your entire aperture and should fit very snugly so there's no chance of it falling off. Now to point your telescope at the sun, now that it's safely covered, the finder scope has been removed. The Rigel, or Telrad if you have such a device, has also been removed. Any of these devices pointed at the sun for a long time can actually be ruined. Not safe to look through either, so make sure those devices are removed. Everything's safe now, so we're going to point it toward the sun. Now how to point your telescope at the sun without a finder, without a Rigel. Look at the telescope's shadow on the ground. When it's as small as you can make it, take a glance through your eyepiece. Again, you're safe with the solar filter. And you should see a round disc go by, and there it is. So now I'm going to lock the telescope in place, and I'm going to focus on the sun's limb, which is the outer rim of the sun. And we're there. Now, once you've got your telescope lined, if you've got a Dob, you're ready to go. If you've got a computerized telescope, you're going to need to synchronize on it. The sun is not in your database for obvious reasons, but since we're doing the transit of Venus, you can lock onto Venus. we're going to tell it today's date, 05 June 2012. The time, 04:44 p.m. Within a minute, that's close enough. Enter. Daylight savings is yes. And now we're going to tell it what we're looking at. We're looking at the object in the solar system, Venus. Make sure that the sun is still in here. It is. So we're going to synchronize on Venus. And then we're going to use the hand controller to move the telescope. And now we have the sun. Although I'm not real happy with my choice of eyepieces. The Nagler is apparently not the best eyepiece for viewing something bright like the sun. These are made for deep sky objects. So, I'm going to put the Nagler away and you're going to use an ordinary Plossy. Seems to actually work better for something as bright as the sun. I'm going to use a 26mm Super Plossy. Now that's a nice view. We've got lots of nice sunspots. I'm going to try putting the camera up to the eyepiece. See if you can see how neat these sunspots all look. There we go. See them? See all the sunspots? Let's do it again. See those little dots in the middle? Those are your sunspots. Now we'll be able to watch Venus make first contact with the sun at 5:04, but we are going to time it. We're going to record the event with the camera and see if we can get an accurate time on it. Go ahead and read it. Go ahead and have a look at the sun through the scope. The sun should fill the field, the big yellow disc. A lot of sunspots, very active right now. So we will be back for the timing of the transit and first contact. Okay, we are all ready to record at least our timings for first contact. The time right now for synchronizing purposes on this video is 5:01, 15 seconds right there. 18, 19, 20. 5:01, 20. Okay, go ahead and take the camera. Now that I've established the timing, all you have to do when you're watching this video is look at the timings on the video itself, and you'll be able to calculate the time that I think I see first contact.
So are you going to put this on the screen so that you can see it, or
no,
am I just going to
you're just going to record me so that we're going to get the timings. And we're going to do the same thing at second contact around 5:22. Okay?
Okay.
Okay, so far I don't see anything. I'm looking all around the sun's limb. In one eye I can see the sun's limb, and the other eye I can see my watch. We are in St. Louis, Missouri. So that date is going to be important for recording and submitting our timing. I've got 5:02 and 22 seconds, 23, 24, 25. I don't expect to see first contact for another minute and a half approximately. Again, it's a subjective measurement. There are a lot of factors that can affect the person's sighting of first contact. Heat, turbulence inside the telescope tube, the atmosphere. I'm getting a lot of both. Nothing yet. Ooh, when I see it, you're going to get a show. 5:03 and 5 seconds right now. I have synchronized my watch with the official time. Remember, this is daylight saving time. time right now in UT, or Universal Time, would be 22 hours, 3 minutes and 30 seconds. 22:03:35. I never thought I'd get to use Universal Time. Nothing yet. I wouldn't expect to see it yet, though. I am using a 26mm Plossl on an 8-inch Schmidt Cassegrain with a Thousand Oaks white light solar filter. Scanning all around the sun's limb. Nothing yet. It's 5:04:20. Nothing. Scanning all around the edge of the sun for that telltale little 1 arc-minute disk of Venus, taking its first bite out of the edge of the sun. The sunspots are in good focus, so my focus is good. Okay. And that right there, bing, is 5:05 and 0 seconds. First contact. We have first contact. I believe I'm seeing it at the 12 o'clock position on the sun's disk. I'm seeing a little bite coming out of the sun. It is 5:05:17. It's obvious now at 5:05:22. We have first contact. I'm going to zoom in a little bit. I'm going to move the telescope towards it. The very top of the sun's disk now. Wow, that's going to be bigger than I expected. Rita, I want you to have a look. We've got about 18 minutes before second contact. I want you to see what I'm seeing and verify that you see. Look at the very top of the sun's disk. You should see a little obvious bite being taken out of it.
I do. I see that.
I wasn't sure exactly where to look, and it kind of turned out exactly where I expected. Right at the top of the sun's disk. I'm not sure exactly at what moment I started seeing it. I'll review the video and I'll be able to tell by my reaction. Go ahead and take another look before I get back to it. This is the 2012 Transit of Venus from St. Louis, Missouri, United States of America. This will not happen again until December of 2117. Let's see if I can get an image on the camera. Let me just give it a shot. This doesn't work really well. I'll leave it up to Gary to take a really good picture. He's imaging right now. But you can see it in this camera. You see a little bite being taken out of the sun there. It's actually visible on this image. Small, but it's there. This is history in the making, folks, and our first participation in the transit of Venus. I missed the one in 2004. That is neat. The neat thing about this is Venus is usually a bright object. Brightest object in the sky other than the sun and the moon. Not now. Now it's the darkest. That is bigger than I expected, isn't it? Don't you?
Yeah, it is.
Yeah, that's amazing. Now, shall we record until second contact, or should we take a break in the video for 15 minutes?
We should take a break.
I think we should take a break in the video, and we're going to come back when we think second contact is imminent. So, we'll be back. Okay, I've got, we're continuing here with the transit of Venus. The official time at the beep will be 5:17. Beep! Okay, let's have another look. because I am seeing about 75% or more of Venus now in front of the sun. The rest of it, the part of Venus that's not visible in front of the sun, is actually visible as a very thin, what they call a ring of fire. And that is, you're seeing Venus's atmosphere illuminated by the sun behind it. Rita, I'm going to have you look at this. This is something that's been talked about in the scientific community. I want to see if you see it. What I want you to look for is, look at Venus as a round ball, right?
Yeah.
Try to look at the part that's not in front of the sun yet, and see if you can see like a thin ring of yellow outlining the rest of Venus's disk.
Yeah, I do.
That's the ring of fire. That's the Venus ring, or the Venus ring of fire, something like that.
That's neat.
But that was only theorized. They weren't sure if people were just imagining it. There you go.
I can imagine it.
But I think I'm really seeing it, because I wasn't really looking for it.
Me too.
Okay. We are preparing here for second contact. Now, second contact is when first contact is when Venus touches the sun. Second contact is when Venus's other edge moves in front of the sun, and an entire disk of Venus is within the sun's disk. We call that second contact, and we're going to time that as well. It's supposed to be about 5:22 p.m. when that happens. The thing about second contact that you look for is what's called the black drop effect. And the black drop effect makes it difficult to see the exact moment when the black disk of Venus completely enters the sun, because the inner part of the sun's disk and the outer part of Venus seems to stretch like a black drop. Is it an illusion? Is it an artifact of optics and atmospheric effects, or is it real? I will tell you if I see it, and if it hinders my attempts at recording an exact time for second contact. It is 5:19 and 35 seconds. Venus is almost completely within the sun's disk. This is so cool. I can't share a moment on video because I want to see it myself. But I will put the camera back on the eyepiece after second contact is confirmed. Now, to me, I've got 5:20 and 15 seconds. To me, it almost looks like second contact is happening now, but I don't think so yet. The blurring effects of the atmosphere are really annoying. I'm going to try to move the view just a tad into a different part of the eyepiece. I still see the ring of fire. To me, it looks like the ring of fire is just touching the edge of the sun's disk. It does look like there's a little bit of extra blackness between Venus and the sun's disk, but it's getting that blackness is getting smaller and smaller. All I can do is narrate. I wish you could see this. The moment of second contact is imminent. There is an ever smaller and smaller area between the sun and Venus. A little bit of turbulence. I don't think we're at second contact yet, although I want to say it's going to be any second now, unless it's already happened. This is a subjective measurement. I don't quite have the black drop effect. That little black spot seems to be shrinking more and more. And it's hard to tell when Venus finally separates itself from the sun's limb. It's any second now, and I'm going to say, oh, not quite yet. There's the black drop, and very small. And I'm going to say that second contact is now. I've got 5:23 and 27 seconds. Okay, Rita, I want you to take a look. Now that was pretty subjective. It seemed like there was a good minute or more where second contact was just happening in slow motion. Venus is a pretty substantial object in front of the sun. It's bigger than you'd expect.
Yeah, I was looking for more of a dot. I mean, a real dot, like a sunspot.
Yeah, it's obvious.
That's awesome. That is awesome.
What?
That's awesome.
Okay, let's see if we can give our viewers a look. Again, I wish I was using a higher quality camera than this cell phone camera, but there's a lot of people doing high quality imaging of the transit right now, so I'll leave that to them. Flatten that down. There we go. It's about as good as I'm going to get with this video camera. You can see Venus there as a black dot, clearly now separated from the sun's limb. So second contact has come and gone. And now the disk of Venus will slowly march across the sun's disk. When Venus begins to exit the sun, that'll be called third contact, and when Venus leaves the sun completely, that's fourth contact. Those are not visible from St. Louis. The sun will have set by then for us. Anyway, thanks for joining us, and this has been the Transit of Venus 2012, June 5th, 2012. First contact and second contact approximately 5:04 and 5:22 p.m. Central Daylight Time.